As a parent or mentor, you have the awesome opportunity to help a young person build a future. So if the future they want is in the military, take the time to learn more at todaysmilitary.com, because their success tomorrow begins with your support today.
New on CuriosityStream.
I'm James Burke. I'm going to take you on a journey through time.
James Burke's visionary series returns, reimagined for our time.
Now, this is all uncharted territory.
The Washington Post hails Burke as one of the most intriguing minds in the Western world. The New York Times raves he careens from one great moment in history to another.
Where do we want to go from here?
Experience all new connections.
So what's the next connection?
With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
This is SpaceTime, Series 24, Episode 10. Coming up on SpaceTime, the most complete map of brown dwarfs ever compiled. The Dark Energy Survey releases its final dataset, and Virgin Orbit LauncherOne flies into space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have compiled the most complete three-dimensional map of brown dwarfs in our stellar neighbourhood. The list of 525 brown dwarfs reported in the Astrophysical Journal includes 38 which are newly discovered. Brown dwarfs are failed stars, objects that don't have enough mass to undergo the core nuclear fusion process which makes stars shine. They fill the gap between the largest planets, which are about 75 to 80 times the mass of Jupiter, the most massive planet in our solar system, and spectral type M red dwarf stars, which are the smallest stars, having about 0.08 times the mass of our Sun. In fact, some brown dwarfs actually begin their lives as red dwarf stars, but become brown dwarfs after losing too much of their mass. The new list of nearby brown dwarfs was compiled by an international team of astronomers, supported by thousands of citizen scientist volunteers in a program known as the Backyard World's Planet 9 collaboration. By identifying these objects and then determining distances to all of them in the census, astronomers have been able to build up a three-dimensional map of the distribution of cool brown dwarfs in the Sun's local neighbourhood. The new dataset blends archival images from the Kitt Peak National Observatory and the Cerro Tololo Inter-American Observatory with sky maps from NASA's WISE, Wide Field Infrared Survey Explorer spacecraft, and new distance measurements from NASA's Spitzer Space Telescope. The result is the best three-dimensional map of the Sun's local neighbourhood ever compiled. One of the most intriguing results in this study is that it provides more evidence that the Sun's local stellar neighbourhood, within roughly 7 light-years of the Sun, is rather unusual. While most stars in the Milky Way are red dwarfs, earlier studies have revealed that the Sun's nearest neighbours are much more diverse, with different types of objects, from Sun-like stars to Jupiter-like brown dwarfs, appearing in roughly equal numbers. And the new results add to this disparity by turning up only one extremely cold brown dwarf, WISE 0855, which just happens to be the coldest known brown dwarf. Astronomers had expected to find several more within, say, 65 light-years of the Sun, given the new study's sensitivity. But that hasn't been the case. This is SpaceTime. Still to come, the Dark Energy Survey releases its final dataset, and Queensland company Gilmour Space conducts a successful rocket engine test. All that and more coming up on SpaceTime. The Dark Energy Survey has released its second and final dataset containing nearly 700 million astronomical objects. The massive international collaboration builds on the previous data release, which itself provided details on some 400 million celestial objects. The research will help astronomers better understand the mysterious force called dark energy, which makes up 75% of the energy mass of the universe, but for which we have no explanation. Dark energy is causing the universe's rate of expansion out from the Big Bang to accelerate. And understanding exactly what dark energy is will help astronomers better determine the ultimate fate of the universe. The findings, which were detailed at the 237th meeting of the American Astronomical Society, has taken 7 years to compile using multiple telescopes around the world. One of the early results relates to the construction of a catalogue of RR Lyra stars. These are an ancient group of population 2 stars, stars made out of the remains of the very first stars to have formed in the universe. Population 2 stars are usually found in globular clusters and in the galactic bulge and galactic halo of the galaxy. But what sets RR Lyra stars apart from other population 2 stars is that they're pulsating variable stars. They all start out as low-mass sun-like stars which have already left the main sequence. That's the stage in their lives when they're happily fusing hydrogen into helium in their core. They then became red giants. That's when hydrogen fusion into helium ceases in the core and the core starts to contract. Now, as the core contracts, the area immediately surrounding the core starts to heat up, eventually reaching temperatures and pressures high enough to begin hydrogen fusion in the shell around the core. This causes their outer gaseous envelopes to expand outwards and, being further away from the core, cool down. The stars have now entered the next phase of their existence, known as the horizontal branch phase. That's when the contraction of the stellar core has increased to the point where temperatures and pressures are high enough to trigger a helium flash, fusing the core helium into carbon and oxygen. Now, at the same time in some stars, those known as RR Lyra stars, pulsations are caused by something called the Kappa mechanism. Now, normally in a star, an increase in compression in the atmosphere causes a corresponding increase in temperature and density, producing a decrease in opacity in the atmosphere, allowing heat energy to escape more rapidly. The result is an equilibrium condition, where temperature and pressure are kept in balance. However, in cases where the opacity increases with temperature, the atmosphere becomes unstable against pulsations. Now, if a layer of a stellar atmosphere moves inwards, it becomes denser and more opaque, causing heat flow to be checked. And in return, this heat increases, causing a build-up in pressure that pushes the layer back out again. And the relationship between their pulsations and their luminosity allows RR Lyra stars to be used as standard candles to measure nearby galactic distances. And the authors of this study have used these RR Lyra stars to tell them more about the region of space beyond the edge of the Milky Way galaxy. In this area nearly devoid of stars, the motion of the RR Lyra stars hints at the presence of an enormous halo of invisible dark matter, which may provide clues as to how our galaxy was first assembled more than 12 billion years ago. Now, in another result, dark energy scientists have used the extensive second data release, along with data from the LIGO gravitational wave experiment, to estimate the location of a black hole merger and, independent of other techniques, infer the value of the Hubble constant, a key cosmological parameter for determining the expansion rate of the universe. Combining their data with other surveys, the dark energy scientists have also been able to generate a detailed map of the Milky Way's satellite dwarf galaxies, giving researchers an insight into how our galaxy was assembled and how it compares with cosmology predictions. The detailed precision cosmology constraints based on the full dark energy survey dataset will come out over the next 2 years. The Dark Energy Survey was conceived to map hundreds of millions of galaxies and to chart the size of the expanding universe as it accelerates under the influence of dark energy. It's now produced the largest and most accurate dark energy map of galaxy-weak lensing to date. Covering some 5,000 square degrees of the southern sky, the survey data enables many other investigations in addition to those targeting dark energy, covering a vast range of cosmic distances, from discovering new nearby solar system objects to investigating the nature of the first star-forming galaxies in the universe. The Australian part of the survey is jointly led by Associate Professor Chris Lidman from the Australian National University and Professor Tamara Davies from the University of Queensland. They use the 4-metre Anglo-Australian telescope at the Siding Spring Observatory to measure exact distances to many of the objects in the survey and to confirm the type of supernovae they were measuring. Lidman describes the survey as the culmination of years of effort, mapping hundreds of millions of galaxies and discovering thousands of supernovae.
The primary aim of the Dark Energy Survey is to understand a little bit more about what dark energy is. Dark energy was first inferred or discovered about 23, 24 years ago by a team of two astronomer teams, and it's been a mystery as to what it actually is. So that's the primary aim of the survey.
How does it go about doing that?
That's a really good question. They're using a number of what are called astronomical probes. So they're using a Type 1a supernova, which is a type of exploding star, using the pattern of galaxy clustering. They're using very massive clusters, and they're using something called weak lensing. That's 4 different astronomical probes, and they're combining them to measure the properties of dark energy. For example, Type 1a supernova, they're using these to measure the distance into these supernova, together with a measure of the redshift, which is the amount of expansion the universe has occurred, to try and measure the expansion history of the universe. They use Type 1a supernova for that. They use galaxy clusters. These are collections of hundreds and thousands of galaxies. They measure the mass of these clusters, and by measuring the mass and how that mass evolves with redshift, they get a measure of how quickly structure in the universe is growing. And that's true also with large-scale structure. They're measuring how fast structure is growing. And through these different probes, they get different viewpoints of what dark energy is. Combine them all together, and they see, oh, dark energy perhaps is like Einstein's cosmological constant, or perhaps not. That's the question, to try and understand what dark energy is through those different probes.
Measuring the distance to Type 1a supernovae, that's where Sighting Spring and the Anglo-Australian telescope comes in, I take it.
That's right, yeah. So the distance is measured through photometry, and the redshift is measured by spectroscopy. And it's the AAT which provides the spectroscopy and the measure of the redshift. You need a combination of both the distance and the redshift, to measure the properties of dark energy. In detail, what you do is you plot redshift to one axis, and you plot distance on another axis, plot your supernova where they appear, and these supernovae will try different areas in this relation, which is known as Hubble diagram, depending on the nature of dark energy. So by having both the distance and the redshift, you get the expansion to the universe and therefore a measure of dark energy. And the AAT was absolutely crucial in that, because without the redshift, you can't make that diagram.
I guess one of the issues nowadays has to be whether or not all Type 1a supernovae are the same, because they're used to measure distance, and the reason they're used is because it was always thought that they always explode with the same degree of luminosity because they all explode at roughly the same mass. How true is that now, but based on what we now know?
It's a very good question, because we now know that Type 1a supernova are not perfect standard candles. They don't all explode with the same luminosity, and so they have slightly different brightnesses. However, it seems that you can look at the properties of the light curve, so that's how the luminosity of the supernova evolves with time, and you can make a correction that gives down out of a sizable candle. And so still not a perfect standard candle, but a perfect measure of the distance, but you reduce the error significantly. But there's still some scatter, some uncertainty in that, so you generally need quite a few supernova in order to beat down that noise.
As well as dark energy, you've been able to find out a little bit more about dark matter as well, haven't you? Because you've been able to study the evolution of our own Milky Way and the region just beyond it using Lyra stars.
Yes. So that's you can measure the motion of these stars, and you can infer what matter is creating those stars to move in that way. But also, more broadly, when you look at the large-scale structures of galaxies, which is something else that the dark energy survey has done, you also infer something about dark matter, or the amount of dark matter, because it is dark matter together with dark energy and ordinary matter, which defines how this clustering of galaxies evolves with time and how strong that clustering is.
I'm going to do something that scientists hate, and you're going to hate me for this, but I'm going to ask you anyway. What's your gut feeling? What is dark energy?
That's a really hard question.
It's a terrible question to ask any scientist, I know.
Yeah, I think that if it's Einstein's cosmological constant, that's one particular theory, then the answer in that question tends to open up more questions as to what is exactly Einstein's cosmological constant. Is it something that's part of the geometry of the universe, or is it something that plays the vacuum energy density of the universe? So that's one answer. I don't know. I don't really have a a good feeling for what it is. If it's just Einstein's cosmological constants, perhaps there'll be a slight disappointment. And maybe we want to find something a bit more exotic, a bit more exciting. But until we take the measurements and analyse the data, we're not going to really know what the answer is going to be. Certainly it's going to take a long time. Analysing these data is going to take a few more years. And then the result may be that it is consistent with Einstein's cosmological constants, but it may also be consistent with other theories. And for that, you'll need to go out and take more data. And now there are surveys which are being planned to do exactly that. For the next generation surveys, like the Large Synoptic Survey, not the Large Synoptic Survey, but the Legacy Survey of Space and Time, which is being conducted, or will be conducted at the Bureau Rubin Observatory starting in a few years.
Is it as simple as the Casimir effect on the cosmic scale?
That's one possibility, yes. That's to do with the energy of the vacuum. So we know that it exists. I think one of the issues with that is the size of the effect. I think if one tries to calculate it from first principles using particle physics, you come up with an answer which is quite different from what you measure. So it could be that, but it could be other things as well. It could be something to do with the way we understand gravity. It might be that our understanding of gravity is not quite complete. It might be that Einstein's theory of relativity is not the full answer, but maybe a more complex Weber theory, which is the right one. Again, it's a possibility, but we don't know yet.
I guess the fact that we're in a galaxy, and the galaxy now appears to be on the edge of a void based on the information we now have, that plays a role too, I understand.
Yeah, if the galaxy is in a large void, so to speak, that affects the expansion rate at the current epoch. So that would have a bias on what we know, what we call the Hubble constant. And that bias occurs for a couple of reasons. But it certainly, Hubble constant is a very interesting number to measure, because currently the different astronomical probes we use to measure things like the astronomical probes, the Hubble constant, the dark energy, give slightly different answers to the Hubble constant. If you use one particular technique, you get a low value. If you use another technique, you get a high value. And the two seem to disagree. The uncertainties are now small enough that the two measurements disagree. What causes that disagreement? It's not clear. Could it be something in the way we're doing the measurement? Or is there some deeper answer which involves perhaps new physics? And that's a very active area of research as well.
That must be very exciting in a way. You're getting these two conflicting figures for the Hubble constant, and yet as you get more and more detailed answers to that question, instead of the differences disappearing, they seem to be growing. They seem to be more stable, depending on whether you're using the cosmic microwave background or supernovae to reach your conclusions.
That's right, yes. So as the data sets are getting better, that tension between the two numbers is growing. And it's not clear what is driving that tension. Is it something to do with our measurements? Or, are we doing something incorrectly perhaps? Or is there something that is really there and we don't quite understand what is causing it?
That must be incredibly fascinating and exciting.
Yes, it is. And there are other examples of that as well. There's another parameter called sigma 8, which is a parameter which defines the strength of galaxy clustering. And different measures are producing different values for that particular parameter as well. So it's not just the Hubble constant in which we're seeing this tension, but we're seeing some tension in a number of parameters. And
that includes things like baryonic acoustic oscillations?
Yep. So BAO are often used to measure the Hubble constant, and also to measure other cosmological parameters like dark energy equation state. At this stage, there's no tension in the dark energy equation state parameter, but as these data sets get larger and more accurate, and we might start seeing some tension there as well. 700
million astronomical objects, that's what was included in this latest data set release. 400 million in the original data set release. You must be getting a fairly decent picture of the universe around us.
Yes, the survey covers about 5,000 square degrees. That's about 1/8 the entire sky which is visible to us here in Australia. And it goes out to pretty much the edges of the universe in terms of depth. Very bright objects, we would see it in the first few 100 million years of the universe, so we would see objects that far away.
You're looking at things nearby and things 13 billion light years away.
That's right. I mean, over those 13 billion years, that goes from formation of the first galaxies, the first quasars, active galactic nuclei, all the way to the galaxies that we see today. By looking at that entire distance, you get to see how galaxies change over time, how they evolve.
That's Associate Professor Dr. Christopher Lidman from the Australian National University. And this is Space Time. I'm Stuart Gary. Still to come, Gold Coast rocket company Gilmour Space carries out a successful engine test burn, and Virgin Orbit's LauncherOne flies into space for the first time. All that and more still to come on Space Time.
If your child is considering something as big as joining the military, you can bet they're taking the time to do some research. You can too, by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Gold Coast-based rocket company Gilmour Space have carried out a successful engine test burn of their new hybrid rocket motor. The hot fire verification test of what is the world's largest single-port hybrid rocket engine lasted 10 seconds, producing a record 91 kilonewtons or 9 tons force of thrust. The Queensland-based company is developing a 3-stage launch vehicle capable of carrying small satellites into low Earth orbit. And the rocket motor used for this test is the same design that will be powering the first and second stages of the company's new Ares orbital launch vehicle. Engineers are now going through the results, with plans to undertake longer duration and higher thrust tests in the next few weeks. This is Space Time. Still to come, Virgin Orbit's LauncherOne flies into space for the first time, and later in the science report, Australian health authorities closely monitoring the situation in Norway following 30 deaths from the Pfizer COVID-19 vaccine. All that and much more still to come on Space Time. This episode of Space Time is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, one of the biggest frustrations and time-consuming parts of going online anywhere is trying to remember and then use all those login details and passwords that you've built up over the years. And again, like me, you probably already have hundreds of them. Of course, on the other hand, you could just be like a lot of other people out there and simply use one password for everything, and that's not a particularly secure idea. But I guess it could be worse. You could be one of those people that use 1, 2, 3, 4, 5 or A, B, C, D, E, or worst of all, you could use password as your password. And with the internet getting more and more dangerous, now really is the time to do something about that. And the good news is there's a great solution out there. It's called LastPass Password Manager. And with it, suddenly all those security hassles are gone. And believe me, the relief really is unbelievable. Not to mention the time it saves you. And it's so convenient having everything stored in the one manageable dashboard. If you sign up for LastPass, you'll be joining some 25.6 million fellow users around the world and more than 70,000 businesses. Now, you've got to admit, that's a lot of trust with one of the most important aspects of online life. And the good news is all this peace of mind is really affordable. If you want, you can simply sign up for the free service and leave it at that. Or for even more features, get the premium package for just $4.50 a month. There are family and enterprise plans available as well. Plus, LastPass works across all devices and even suggests super secure passwords for you to use. So why not put your passwords into autopilot and reduce the stress? You can check out LastPass at spacetimewithstuartgary.com/LastPass. That way you'll be helping to support our show. So sign up and use it for free at spacetimewithstuartgary.com/LastPass and simplify your life. And like always, you'll find the link details in the show notes and on our website. That's spacetimewithstuartgary.com/LastPass. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
Richard Branson's Virgin Orbit has successfully delivered its first satellites into space, drop launching its new LauncherOne rocket from beneath the wing of a Boeing 747 carrier airliner off the coast of Southern California. The modified Boeing 747-400 named Cosmic Girl took off from the Mojave Air and Spaceport in the desert north of Los Angeles, flying out over the North Pacific Ocean to a launch point beyond the Channel Islands. It then drop-launched the 22-metre-long LauncherOne rocket from a specially modified mount on the port wing between the fuselage and the number 1 or left inboard engine. Now, this mount is an anchor point normally used to carry spare jet engines. The two-stage LauncherOne rocket then carried its payload of 10 CubeSats into low Earth orbit, where they were all successfully deployed. LauncherOne can carry up to 300 kilograms into a 500-kilometre high sun-synchronous orbit.
Elsie, this is LD in control room. We are currently on track for our nominal timeline, and our current drop time as listed in Trillion is 19:25 UTC.
Planet controller and flight crew has been boarded the aircraft.
Cosmic Girl, this is Orbit Base. You are go for takeoff.
Copy, go for takeoff.
Altitude 3,000.
And Orbit Base, Cosmic Girl is starting the turn to the inbound. Pulling now. Pull.
Pulling.
Release. Release, release, release.
EST's ignited.
Confirm Newton 3 engine startup.
Max Alpha achieved. TBC's in first stage looking good.
We had a pretty awesome view up here.
Max Q Alpha achieved.
Stage 1 burn nominal.
Stage set, brake wires broken.
Newton 4 startup complete.
Recovered, and we are now returning to base.
Bearing, brake wires broken.
LauncherOne's in space.
Sounds like the blue sky went to black.
This is Radiohead on control. Mauritius has confirmed acquisition signal. Payload separation confirmed.
This successful orbit insertion follows a failed attempt 8 months earlier. The May 2020 failure was caused by a breach in a high-pressure line carrying cryogenic liquid oxygen to the first-stage combustion chamber. Northrop Grumman Orbital Sciences use a similar air launch system for their Pegasus rockets, which had drop-launched from the belly of a specially modified Lockheed L-1011 TriStar airliner called Stargazer. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Health authorities in Australia say they're closely monitoring developments in Norway following the deaths of 30 elderly people after being given the Pfizer vaccine. Australia's Therapeutic Goods Administration says the 30 fatalities came out of 40,000 people who had so far received the mRNA-based vaccine. It's claimed those who died were all frail with a range of other medical conditions. Researchers say they now need to determine if the vaccine complicated those other conditions. Professor Bruce Thompson, Dean of the School of Health Sciences at Swinburne University, says while the deaths are a concern, scientists still need to understand if the fatalities are associated with the vaccine or because of other medical issues. More than 2 million people have now died and more than 100 million have been infected by the COVID-19 pandemic, which spread globally out of its Wuhan epicenter after the Chinese government ordered local doctors to cover up the seriousness of the deadly disease. A new study has found that taking vitamin D supplements won't protect you from getting coughs, cold and the flu. The findings, reported in the Lancet Medical Journal, show that the supplements won't protect you from acute respiratory infections, but may slightly shorten the length of infection, and could also help ease the severity of those illnesses. Researchers analysed the health data from 1,600 Australians aged between 60 and 84 who were given either a capsule of 60,000 international units of vitamin D or a placebo every month for up to 5 years. The trial showed that people given the vitamin D supplements were infected with colds and flus at the same rate as those given placebos. Researchers point out, however, that the trial was conducted in sunny Australia, where people are generally not vitamin D deficient to start with. European powers are raising concerns over Iran's plans to produce uranium metal, warning that Tehran has no credible civilian use for the element. The joint statement by British, French and German governments warns that production of uranium metal has potentially grave military implications. Producing or acquiring plutonium or uranium metals or their alloys would be yet another violation of the 2015 Vienna nuclear deal agreed to by Tehran. The International Atomic Energy Agency says the Islamic Republic confirmed that it was advancing research on uranium metal production, claiming it was for a research reactor in Tehran. The United Nations nuclear watchdog is already concerned about one missing metal disk of uranium, the type used in a thermonuclear weapon, and the location of other undeclared nuclear material that's been missing since Iran's earlier nuclear research activities in the early 2000s. The latest developments follow recent revelations that Iran's enriching uranium up to 20% purity, well beyond the 3.67% it agreed to under the 2015 United Nations Non-Nuclear Proliferation Treaty. It comes at a time when Iran's nuclear stockpile of enriched uranium is now more than 11 times greater than that agreed to under the Vienna Accord. Tehran's also prevented United Nations nuclear watchdog inspectors from entering several sites suspected of containing undeclared nuclear material and other nuclear-related activities, another breach of the 2015 treaty. And the Islamic Republic is continuing its development of ballistic missiles capable of delivering thermonuclear warheads, yet another violation of its nuclear non-proliferation agreement. The oil-rich nation insists its nuclear program is exclusively for peaceful power generation purposes. Meanwhile, the Islamic Republic's close ally, nuclear-armed rogue state North Korea, has unveiled its new submarine-launched ballistic missile. 4 of the missiles, fitted with black and white nose cones, were displayed during a Communist Party parade in Pyongyang. The North has shown off smaller submarine-launched ballistic missiles before, and it's even broadcast footage of a test launch. But it was not clear whether they were fired from a submarine or from an underwater platform. A working submarine-launched nuclear ballistic missile would be a strategic game-changer for Pyongyang, allowing it to launch a surprise attack from close to the United States, even if its land-based forces had already been destroyed. The new missiles follow similar revelations back in October, when North Korea rolled out what analysts described as the world's largest road-mobile liquid-fueled intercontinental ballistic missile. The monster weapon was so huge, it needed a specially modified 11-axle mobile launcher vehicle. Well, CES, the world's largest consumer electronics show, has just wrapped up in Las Vegas. But the annual event was very different this year, being held virtually due to the COVID-19 pandemic. Still, it featured all the usual advanced technologies that will become the next gotta-have gadgets to grace our homes. A look at some of this year's offerings. We're joined by Alex Zaharov-Reutt from ITWire.com.
Last year, there were nearly 200,000 people in physical attendance. But of course, this year, with the pandemic, they made the decision mid-last year that it had to be virtual. And really, there's not a lot of things that they could have done differently because of the virus. So they had to do it virtually, and look, they had a great attendance. I mean, all the different companies were there. They were doing online virtual tours of the various stands, and they did the best that they could do. There were robots there. There were smartphones with rollable screens. There were, all sorts of interesting touchless technologies in terms of touchless video doorbells that lit up when someone comes to leave something at your door, and a lot of masks. Masks with Bluetooth headphones, Bluetooth microphones, because your mask is muffled. But of course, there was also the flying cars.
Yes, where is my flying car? When I was a school kid, I was promised a flying car when I grew up. Forget the hoverboard, I was wanting a flying car.
The problem with flying cars is it looks great in movies like The Fifth Element, where they have these special zones where cars can fly. But in the real world, people have enough difficulty maintaining their cars that go on the road. If they don't maintain their flying cars properly, they'll be falling out of the sky. But of course, it is a beautiful thing to dream about.
I think the idea with the cars that what we saw at CES is that they're all autonomous. They fly themselves, so you don't need that pilot's license. You're literally there just as a passenger.
Yeah, look, they're kind of a hybrid between cars and helicopters.
Yes.
They're called VTOL, which stands for vertical takeoff and landing. And of course, at the moment, in 2021, it's all about electric VTOL. And so that's more or less a type of a helicopter. And this year was Chevrolet. Last year it was Toyota. The year before that it was Hyundai. Bell Helicopters has also had a VTOL multi-rotor craft. So there's been a number of different takes on this. And of course, when you look at the details, Chevrolet's aircraft or the flying car was a concept. It was virtual. I mean, everything was virtual. You know, the whole of CES was virtual. So we don't really know whether this thing actually exists in the flesh. I mean, that would have great looking prototypes. And I remember 2 or 3 years ago, there were prototypes of drones. And it is possible for it to be autonomous. You get in, you type in an address you want to go to, and it takes you. And it will either land in a designated roof of a building or in a designated area. And probably by 2030, these things will be all over the place. But at the moment, there's still more science fiction than fact.
I guess the other point worth making also is that these things aren't really flying cars. They're simply aircraft. If they were cars, they'd also be able to travel along the freeways and motorways and the local streets, and they don't really do that, do they?
That's exactly right. I mean, we have seen car concepts that had sort of wings that popped out, and some of these were from the 70s and 80s and 90s, and they were sort of half cars, half planes. But really, it's all about being able to take off vertically. I mean, you don't want to have to take off like a conventional plane. No, that would be crazy. So this technology is something that will definitely be in our lives over the next 10 to 20 years. We need to really improve the battery technology. At the moment, you're lucky to be able to get to one place before needing a recharge because you need batteries that have the energy density that jet fuel can provide, and that doesn't exist yet.
We're getting close with the latest developments in capacitors. I think 3.7 is where they're at now. So they're getting towards that battery energy density, the density of a lithium-ion battery.
I remember being at an Intel event in Beijing, and at the time they were saying that Moore's law talked about the number of transistors in a processor doubling every 18 months. Well, they explained at that particular event that the battery technology enabled the battery density and the life of the battery to double, not every 18 months, but every 18 years. Still think it'll be 10, 20, 30 years before we have battery technology that can truly replace everything in our lives that is currently a motor or nuclear or steam powered or whatever it might be. And, you really want something that is the size of a walnut that can power your life for a year. I mean, that would just be the holy grail.
Well, it's not going to be hydrogen. The hydrogen economy never happened because they never, dare I say, cracked the nut on how to store the hydrogen safely. That was the big problem there and it remains the big problem. So the hydrogen economy isn't going to be it. And that's what it leaves us with a battery or capacitor economy of the future. And I think that's really the way we're going now. What else was at CES this year?
There was some robots from Samsung. One interesting robot looked like one of those tower fans on wheels, but instead of just being something that blowed hot or cold air around, it had this arm that popped out of the top of it. And there is a video online that you can watch. Just type in Samsung CES robots. And this robot I think it's called a Handy, and it can unpack your groceries. It can pack your washing machine. It can pour a glass of wine for you. It can clear the table. It knows how much pressure to use on different types of cutlery and other household objects so as not to crush them. And this was a robot that's sort of meant to improve your home life. This was sort of, again, a bit of a concept. It will be some years before it's available. But they did have a different robot that was sort of like a very primitive version of an R2-D2, and it would run around the house. It would tell you if it saw you working that you needed to take a break.
It's like Rosie. It's like Rosie on the Jetsons.
That's right. But smaller. But it also has a built-in screen. So, for example, if you had an upcoming video call, you could say, hey, your video call's about to start, and then it would display it to you. So, these are the very beginnings of the sort of sci-fi robots that we've seen in all the different TV shows. It really has started off with the mobile phones being the brains of these sort of devices. And, of course, now we have wheels and we have hands. We have the mobility of these devices, but it's only going to blossom and incredibly improve over the next decade or two. And it may well be that we'll have the Japanese dream of having robots looking after the senior citizens really will come true within our lifetimes.
That's Alex Zaharov-Reutt from ITWire.com, and we'll have more from Alex and CES later in the week. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.